Stan Gibilisco here. I would just like to talk a little bit about current and signal flow in a very simple circuit. This circuit here is an amplifier circuit, a generic amplifier circuit using an N-channel junction field effect transistor. It's just provided as an example of a amplifier that you might find in a radio receiver or possibly an older audio system, weak signal amplifier with an input over here at the left and an output that goes to the next amplifier stage, whatever that may be. You might think of this as, say, a microphone preamplifier in an old tape recorder circuit. Remember those? I have an old reel-to-reel tape recorder circuit, or maybe a radio frequency amplifier. Seeing as this is shown as an air core coil, that'd probably be a better representation. Maybe what we should do is add here a variable capacitor. Why am I adding that, you might ask? That will tune this particular circuit right here to pass signals that come in from, well, let's just say a radio antenna, like a short-wave radio antenna. Now we have a radio frequency preamplifier and preselector stage. The signals, let's deal first with the signal flow. That's somewhat different than the current flowing in the circuit. The current that flows comes from the power supply, 12 volts here, but the signal is an alternating current, very high frequency alternating current, radio frequency signal, which flows back and forth at millions of cycles per second, millions of hertz. Say that maybe we have an amateur radio set up and we want to operate on, 10.1 megahertz, something like that. So we tune this circuit so that it optimizes the signal as it comes in at 10 megahertz. It sort of reverberates. It causes the circuit to prefer this 10.1 megahertz frequency. The signal can pass through this bypass capacitor easily to ground on this end of the coil, but we still are able to obtain bias for the transistor through this resistor. Here's the field effect transistor. The signal flows in between the gate here and the source here. This resistor provides the proper voltage on the source, so the signal flows through here, and that regulates the amount of current that can flow through this channel of the junction field effect transistor, sort of like squeezing on a garden hose and then releasing it and squeezing it and releasing it millions of times per second changes the intensity of the current, the direct current that flows through this circuit. Current, we can think of it as electrons flowing. Direct current is a flow of electrons from negative to positive. Now the common ground here serves as the negative terminal of our circuit. In fact, we might have a 12-volt battery with the positive terminal connected here and the negative terminal connected to this common ground. So the electrons will flow out of the negative through here and back to the positive 12 volts in a varying fashion. This capacitor right here is a blocking capacitor. It prevents the direct current 12 volts from getting into the next stage and messing it up, but it lets the alternating current portion of this fluctuating signal pass on through. So the signal flows in here. This device, this junction field effect transistor, regulates the flow of direct current in accordance with the fluctuations of the signal so that we get a fluctuating direct current here. This capacitor lets the fluctuations on through, but not the direct current part. So the signal flows in through here, gets regulated, amplified, we hope, so that it comes out stronger and goes on out there. Electrons will flow from the common ground through here back to the plus 12 volts, and also to some extent they will flow here But we don't really want current to flow between the gate and either the source or the drain of a field effect transistor. This simply provides an electrostatic voltage here on this gate. So current actually flows, electrons flow through like that. Now sometimes you'll hear about conventional current. Conventional current. Now this is going to get confusing. And it's really too bad that people even talk about this at all anymore. But in pure physics courses, you may hear that current flows from plus to minus. Well, current doesn't really flow from plus to minus. That's an old-fashioned convention from way back in the days before scientists even knew that electrons existed and could carry electrical charges. So convention has remained intact even though it defies common sense. When you think of current, for most intents and purposes in our hobby electronics endeavors, we would think of it as electron current flowing from negative to positive. And yes, current does flow out of the ground. This common ground here eventually will go to an earth ground, so current is in fact flowing in a sense out of the common ground and back into the battery, where it flows through the battery and goes back on here to the ground again in an endless loop. You need to have a closed circuit in order for a current to exist. Without a complete loop or closed circuit, direct current can't flow. Unless you have, say, an infinitely long wire or something, but that's a theoretical ideal. That doesn't happen in the real world. So we're talking here about tracing the flow of a signal through this amplifier. It goes in weak here and comes out stronger here, maybe 10 times as strong. And the reason it does is because this device is specifically designed so that small changes in this voltage between the gate and the source produces large changes in the current from the battery that flows through this junction field effect transistor. If you need more information about this and related topics, I recommend a complete electronics course. That is my book, Teach Yourself Electricity and Electronics, a link to which I will provide in the description of this video. Stan Gibilisco saying so long for now. Hope you got a little something out of that.